When my kids were little, I made sure to go into their schools to try to do a science day, once a semester. And I would do this both for the kindergarteners through the first grade, second grade, third grade, fourth grade, do it for a whole bunch of different classrooms. And when you're thinking about that, what kind of science can you teach a bunch of 5-year-olds, kids in kindergarten? And I thought, what are some of the basic questions that people want to know about? And I think a very, very basic one that I'm sure every young child asks is, why is the sky blue? I'm going to tell you. So, here's the basic deal. Light, the light coming from our sun, is not one single color. It's not one single wavelength. It actually has a whole spectrum. And if you use something like a prism, you can break up the light into its colors. So what happens is, in this case, the white light from the sun comes through, and then it hits a certain piece of material, and this material, glass in this case for a prism, actually has a characteristic that different wavelengths will go through the prism in slightly different directions, something called index of refraction. And what that means is that it will split out the red light. It won't bend it as much. That's maybe at 700 nanometers wavelength. But the purple and blue light, which is around 400 nanometers in wavelength, it will bend much more. The entire solar spectrum actually has light over a much larger wavelength range. If this is going up in energy, the peak here is actually at green. And it's not by coincidence that our eyes are able to see the absolute peak of the solar spectrum. This is called the visible. Now, in higher energy, we have ultraviolet. Lower energy, we have infrared. And in this prism picture, even though our eyes can't see it, if this was light from the sun, indeed, there'd be some infrared up here and some ultraviolet down here. Here's an actual picture of a prism, and the colors may not be as intense, but you do see that you get this split. And if we go way down here, the one color you can absolutely see is green, because that's the peak of our solar spectrum. It's also the peak of our visual acuity. The solar spectrum and our eyes grew up together. So a prism-shaped piece of glass is a nice curiosity. But you know what? There are things that will refract the light in nature, and you will actually be able to see the solar spectrum spread out for you, just about any time after a good rainstorm, if we've got some sunshine coming to it. A rainbow is droplets of water acting as a prism. To see a rainbow, the sun has to be going through a rain cloud. It has to be going through water droplets. And then, indeed, you'll see the red, yellow, green, purple, beautiful rainbow spectrum. How does this actually happen? This is the deal. A triangular piece of glass can refract light, but so indeed can a spherical droplet. The rain starts splitting it here. Then this is just like a normal mirror reflection at this point. And out eventually comes all of our colors. It's also a very important number here, 42, the answer to everything in the universe. 42 degrees happens to be the angle that the visible light spectrum will be spread at for internal reflection in a sphere. So this is really cool physics, how a sphere can act just like a prism and break up the light according to its wavelengths. But how does that make a rainbow? Well, let's say I'm standing here, okay? And, here we go, and I'm looking up this way, and somewhere up here, there's some raindrops, all right, a bunch of spheres. If I'm going to see a rainbow, what do I need? Well, I need at the right angle, at 42 degrees, I need the sun. Hi, Mr. Sun. All right, there we go. We got the sunshine, 42 degrees. The light, the raindrops scatter the light. And what I see beyond here is my beautiful rainbow at that angle of 42 degrees with respect to the sun. Next time you're out looking for that pot of gold, just check it out. So this still doesn't explain why the sky is blue. The sky is blue because the sunset is red. What is that again, Professor Ruzick? The sky is blue because the sunset is red. Let me show you. So just about anything in the atmosphere, even the molecules of air, scatter light according to a very interesting physics formula. 1 over the wavelength to the 4th power. That's really, really strong and really something. So blue light, okay, is higher in energy, closer to the ultraviolet rays. That means it's lower in wavelength. It has a wavelength around 400 nanometers. Red light, on the other hand, is lower in energy, closer to the infrared, and it has a wavelength of 700 nanometers. Now the difference between 1 over 400 to the 4th power compared to 1 over 700 to the 4th power is enormous. It's actually a factor of 10. If I put this in microns, this one, 1 over the 4th power is something like 40, and this one, 1 over the 4th power in quadratic microns, is 4, a factor of 10. So what does this mean for sunsets and blue skies? So here I am on the Earth. All right, here we go. Stick figure me. All right. And I am looking at sunset. So somewhere over here, we've got Mr. Sun again. All right, there's my sun. Mr. Smiling Sun. And the light coming from the sun, remember, has red, it's got blue, it's got all the colors. But because of this, the blue light scatters much more. Remember, this is scattering. That's proportional to 1 over the wavelength to the 4th power. So the stuff that scatters the least is the red light. The blue light coming up here, boom, scattered. More blue light coming out, boom, scattered. Let's make the Earth a little rounder. Blue light coming out, boom, scattered, 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 scattered. And what do you see when you're standing here? Not over here where the sun's setting, but over here in Hawaii. You look up at the sky. Not right at the sun, but you look this way. You see all the scattered light. You see the blue. Because the scattering is so strong and so wavelength dependent, the red light just keeps going straight through the atmosphere. And the blue light gets bounced all around. So you look up, you don't have to look at the sun, look anywhere. And what do you see? You see the stuff that's been scattered the most, the blue light. Only at the very end of the day will you see the light coming straight through, the red light, the sunset. The sky is blue because the sunset is red. So remember how I told you that the maximum of the solar spectrum is green? And I just showed you that we see a red sunset and we see blue light scattered. Well, where did all the green go? Well, it's somewhere in between, of course. But that means if you're really, really careful, after the sun sets below the horizon, you might be able to see the green. And this is called a green flash. I've seen this 3 times in my life, but there's a beautiful picture of it. Right here, the sun had just set, and right as the sun dips below the water, the green light, which has been scattered a little bit, not as much as the blue light, but a little bit, is now visible. Here's an even better picture. The top frame here is the green flash at sunset. And then if you zoom in on this, and of course you zoom in on it in a time lapse so you can watch the sun dipping below, you see this, you see still some of all the yellow colors, you see the deep green, and as you might imagine, it's now going to keep going through the rest of the solar spectrum into a little bit of the blue and then disappears. So the sun has all of the colors, and the rainbow shows it to you vividly. But sunset can also act the same way if you get the conditions just right. That's what you need to know about why the sky is blue.